Problem 12 asks us to use the three conditions of continuity to determine if g of x is continuous at x equals 1. So the first condition would have to be that g of 1 exists, and in this case g of 1 exists or is defined to be 2. So at x equals 1, y is 2. The second thing we have to show is that the limit coming from the left of this function is equal to the limit coming from the right of this function. And left and right of 1 are going to have to do with the first part of that piecewise function. So over to the side, I'm going to get organized to graph that. I'm factoring the top, x plus 1 times x minus 1 over x minus 1. I have those factors that cancel out, so I know there's going to be a whole at x equals 1. And besides that whole, the rest of the graph is just going to be a linear function, the linear function x plus 1. So I'm going to start my function at a y-intercept of 1. We go up 1 and over 1, but we have a hole at 1, so put my hole there. Up 1 over 1. It's very hard to plot points on this tablet. Connect, and that's what your function looks like. So if I look at the graph coming from the right side of 1, my graph is approaching 2, and coming from the left side of 1, my graph is approaching 2. So the limit as x approaches 1 from the right is equal to the limit as x approaches 1 from the left. I should put my f of x in there. And both of those are equal to 2. And then the third condition says that part 1 and part 2 have to be equal. G of 1 has to equal the limit as we approach 1, and from the left and the right we are approaching 2. So g of 1 equals the limit as x approaches 1 from both sides, and both of those are equal to 2. So if I plot right here, go over to 1, comma 2, we fill in the hole, and we have a continuous graph. So g of 1 is defined, the limit exists because the limit from the left is equal to the limit from the right, and the function, where the function is defined at 1, is equal to what we are approaching as we get closer to 1. So this function is continuous at x equals 1.